Hi, good afternoon everyone. Welcome to another gorgeous day in Northern California here. My name is Rocky Peruke, and today I'm making a video about how to build your own vortex machine. This is for Linda Borghi's podcast on that subject. I recently attended several lectures given by Linda about creating vegetable gardens or farming your own yard. And as part of that lecture series, she introduced us to a concept of activated water, which you can make by hand or using a vortex machine. If you want more information on this subject, there's certainly a lot of it on the internet about activated water and vortex machines and on Linda's website, farmyard.com. But today, this video is about how I made my own version of a vortex machine. So what does a vortex machine do? Well, it makes activated water. And activated water is actually a fourth phase of water that is created by swirling water in one direction to form a vortex. Then you interrupt that flow, create chaos, and then form a vortex in the other direction. This process needs to be repeated about every couple of minutes for about an hour. And again, you can do this by hand, or you can make a vortex machine to help you with that process. So this video will be in two parts today. The first part I'll describe the components that I use to make my vortex machine and discuss some of the assembly tips. And then in the second part, I'll fill it with water and show you how it works. So right now I'm going to stop the video and come back when I've disassembled it a little bit. Okay, so now you see I've disassembled it a little bit, and I want to show you the components that I use. So first of all, a bucket, 5-gallon bucket. You can buy that at any hardware store. I got this at Home Depot. And then in the bottom of the bucket, you'll need a feed-through fitting. This is basically just where the water exits the bucket at the bottom. So you'll need that. And you can find those generally in the water heater department at the hardware store, not usually with the normal plumbing components. So look in the hot water heater section, and you should be able to find one. Very easy to screw into the bottom of the bucket. You have to drill a 1-inch hole. Then you've got here I've got a 90-degree elbow coming out, and then tubing running to the inlet of the pump. You don't need this fitting I have here. I tried something, didn't work. So I've got tubing, 3/4 inch tubing. I used 3/4 inch tubing in the design because I wanted something very rigid to hold the bucket in place. So the 3/4 inch worked really well. So then you need to adapt. I've got an adapter here that goes from the 3/4 inch tubing to the pump inlet fitting. You'll have to figure out, this happens to be a 3/4 inch PVC to, I believe it's 3/4 inch pipe thread. And then that fitting, I found a fitting that adapted the tubing to the pump inlet. The pump that I chose is a 800 gallon per hour pump. 600 gallons is about what you get out of a garden hose, and I figured that was about the right velocity to the right flow to create a good vortex, and it actually works pretty well. So this is an 800 gallon per hour pump, and it works just fine. Then out of the pump, the outlet fitting came with the pump. There's a shutoff valve, and then that shutoff valve then screws into a T fitting. So this is I believe it's a 1/2 inch pipe thread fitting to PVC tubing T. And then here the flow splits into two directions. So on this one side you've got some tubing. You'll need about 4 feet of 3/4 inch PVC tubing, another elbow. You'll need 3 shutoff valves, and I'll explain the purpose of the 2 valves on the one side a little later on. Another T fitting on both sides. Then on each side you've got some 45 degree, so 3/4 inch 45 degree fittings. Then there's an adapter to go from that fitting, 3/4 inch to 1/2 inch pipe. For these flexible tubing, you can buy these flexible tubing lines pre-made at the hardware store, which is really nice. So I just screwed those into an adapter and then hold those to each side of the bucket so the flow comes out each one of these in different directions. And then I used some U-clamps, which you can also find at the hardware store, to just hold those in place. So that's pretty much it for the bucket. Then in addition to that, I've got a tray, a plastic tray with a lid. I cut a hole in the top so I can insert the bucket and pump without opening the lid. The lid is nice because it helps keep the side rigid when this is filled with water, and I'll talk about that in a little bit. I've got some blocks inside to set the bucket on, so the bucket rests on the blocks and keeps the bucket at the same level as the pump. I have a small submersible pump. This is about 120 gallons per hour. You could probably get away with a 70 gallon per hour. This is just to pump some of the water that flows through the submersible pump into the bin to pump that water back into the bucket, and I'll explain why I needed to do that in a bit. So those are basically the components that you've got in the system. All of these components can be purchased at your local hardware store, and some of them you'll need to go to maybe a pet store for the smaller pumps and stuff. Tools you need, it's a good idea to have a PVC tubing cutter. They don't cost much, and it makes cutting the tubing much easier than trying to do it with a hacksaw, but you can certainly use a hacksaw. You'll need some PVC primer, an electric drill, a 1/4-inch drill bit, 1/4-inch drill bit to mount the U-clamps, and then a 1-inch drill bit to mount the fittings in the top of the bucket and the feed through at the bottom of the bucket. And then probably just an assortment of other common tools, pliers, screwdrivers, and so on. Now, one thing I want to point out about my choice of a submersible pump is that was somewhat by accident, but it works in this application and really is the reason for the large plastic bin. I purchased the pump at Home Depot, and 2 different associates assured me the pump did not have to be submerged, which is probably what I wanted to hear. So taking their word for it, which is kind of unusual for me, but actually fortuitous, because I forewent reading the instructions and just went directly to constructing the prototype. But then upon powering it up, I noticed water leaking from the pump, and I soon discovered that the pump diverts some of its intake water through the pump and then out through a small discharge hose, a hole in the back of the pump, probably for lubrication or cooling. But for whatever reason, some water does flow through the pump. After researching some of the options for non-submersible type pumps, which are much larger and more expensive, I just decided to solve the problem by putting the bottom half of the bucket in a bin so that the pump would be submerged. That solved my problem, but it required that I periodically scoop some of the water that circulates through the pump from the bin back into the bucket. And it's about 700 mils per minute, so it wasn't much, but and I didn't see this as a big issue, as you really need to attend the process anyway to switch the valves every couple of minutes. So it wasn't any big deal, but eventually I decided to put a small pump. This is a Danner 120 gallon per minute pump. So I decided to put this in the bin to pump that water automatically back into the bucket. It's your choice if you want to add this second pump. It's not really necessary, but just makes it a little easier. The hose end, so from the small pump, originally I put a fitting on the end, just a cap, and drilled a hole in it to give me about I kept enlarging it till I got about 700 mils an hour, so it would maintain the same flow as it's going through the pump that same amount of water back into the bucket. And that worked pretty well, but then I eventually realized I could just drill a larger hole and let it flow if I just drilled a hole in the bucket at the level I wanted to maintain in the bucket. So I drilled a 1/4-inch, 1/2-inch hole in the top of the bucket so that water just continually drains out and it dribbles back down into the bin, so it works just fine. So I put a little piece of tape over it, some metal tape over the hole, just to keep the water flow diverted downward. There's a more elegant solution probably than that, but the tape worked just fine. My next prototype I may do something differently, but anyway, this system actually works quite well. So as I mentioned, I got the feed through in the bottom of the bucket at the water heater department at Home Depot. The pump outlet So at the pump outlet, you can see that it splits into two different directions, one to each side of the bucket. And the valves are manually opened and closed to force flow one way or the other to create a vortex in one direction or the other. And they're operated manually, but that's fine. These particular valves that I bought, these PVC valves, work a little hard. They work a little easier when there's water flowing through them, but they're a bit hard to work. And in the next design, I might put a little different valve in there, maybe a brass valve with a handle that works a little easier, but they work fine for now. On this side of the bucket, I've got two valves, and the reason I put two valves in there is so that I could close off flow, keep the pump running, close off flow to both sides, but open this bottom valve, and then that diverts water to this hose coupling. So you can attach a hose here, and you can either pump the water from the bucket into another bucket, or you can attach a longer hose and just water your garden directly with the pump running. So that actually works quite well. Some of the glued fittings, another thing I want to point out is some of the glued fittings, alignment is very important, is very critical. So when you put all the fittings together and you do a dry fit of the assembly before you do anything, when you got it all aligned the way you want it, there's certain pieces that need to maintain alignment. So I put alignment marks on either on the fittings on either side of the junction, so that when I assemble them, I can keep those aligned and make sure everything is aligned properly. So that's kind of an important thing to do. And then lastly, you'll need to pay attention to the order in which you glue up the fittings, because you want to make sure when you glue the last couple of fittings that you have enough flexibility. I found that gluing this fitting last, because these arms tend to move out freely enough, so I glued these junctions last. So glue all this up in place first, making sure you get good alignment, and gluing these last seemed to work well. So now I'm going to stop the video. I'm going to fill the bucket, put everything in place, fill the bucket with water, and then show you how it works. I'll be right back. Okay, so now I've filled the bucket with water, and all we need to do to turn the system on is just plug in the two power cords for the pumps. Starts the pump up. This is the line, the water that's running from the bin, recirculating the water from the bin back into the bucket. I just kind of tuck that in there. I open the valve on one side. Now I'm getting a swirling started. It's going to form a nice vortex. So what I'm going to do at this point is I'm going to shut the video off. I'm going to zoom in a little bit so you can see it, and then start the video again. Okay, so I've got it started, and as you can see, I hope you can see in the video, we've got a very nice smooth vortex running in this direction, and you can see the water. This is the water that's draining back out the top of the bucket, flowing back into the bin. Got to do a little work there so I get a little better flow, but anyway, you get the idea. So when we want a reverse direction, I'm going to zoom out a little bit. I'm going to stop the video, zoom out a little bit on this. Okay, so what I've done now is zoomed out a little bit, so we'll change direction. So all we need to do is close the valve on one side, open both valves on the other side. I just switched this line over to the other direction. And now you can see it stopped, created a little bit of turbulence. Now it's starting to spin in the other direction. So I'm getting a nice vortex. It's starting to form now, you can see it. In a second or so it'll, and you can actually hear it. It has a nice pleasant sound as it forms the vortex. So you let it run for a minute or so till it gets a good vortex going, and then you switch it to the other direction. So I'll do that one more time so you can see it. So we'll close off one of the valves on this side, open the valve on the other side, just move my line up here at the top. Got some nice turbulence going, flow now going in the other direction to create a nice vortex. So I let this run about 2-3 minutes in each direction, and then switch the valve. So do this for about an hour to create activated water. When you're finished then, so what I do when I'm finished is I just close the valves, close all of the valves. Then you can remove this cap from the hose end fitting. I attach a small hose. Generally I just put a small hose on there and run it into a bucket, another bucket. So once I've got that hose attached, then you can just open the lower valve and water will then flow to that hose into another bucket. And I think that's about it. So hope you enjoyed this video. I hope it's helpful. If you have any questions, you can contact Linda and she'll be happy to provide you with my contact information, and I'd be glad to answer any questions that you have. So happy farming and have a great day.